Hello, everyone. I'm Joel Henderson, and welcome to my first progress report for weeks 5 and 6 of my Indiana Tech College of Engineering Capstone project. As I mentioned previously, I'm doing an analog guitar pedal that has multiple effects on it. Here are all the topics that I'll be covering during this presentation. The problem: you can mix and match different effects to create your own signature sound, but the problem with that is that mixing and matching all the effects pedals can become pretty expensive after you accumulate a big number of them, and it can get pretty unorganized quickly. Digital effects and the pedal boards, they helped out with this, but they have their own caveats. Like digital effects, for example, have a wide variety of preload and programmable effects, but they're known for being unreliable and sounding different from the analog effects. Pedal boards and racks are handy when you're using multiple pedals, but they have limited portability and they still require all the same cabling, and you still need to organize the pedals. Trying to find some of the old legacy pedals that aren't made anymore can be pretty difficult, since people like to collect the originals. And analog pedals that had 2 to 3 effects on them were pretty common in lineups during the 80s, but in the 80s is when the digital effects started being produced. And after the digital multi-effect panels became more common, uh, you started seeing the decline of the analog pedals. The solution. The solution I devised is a blend of new and old to design an older style effects pedal while using modern components in design. Since technology and manufacturing techniques are more advanced than what they were in the 80s, creating a rugged and dependable 4-effect pedal is something that I can accomplish. You can find these things on blogs, forums, like Pedal PCB, Mean Bean, Pedal Land, Coda Effects, that have libraries of basically every effect diagram of every type. By making modifications to the diagram, you can make a pedal that sounds completely unique. I plan on changing up some of the components that are being used in the circuits so that I can have my own spin on some of the sounds that come out of it. The process. The plan that I'm implementing hasn't really changed from my proposal. I've added a few things though. Research the circuit diagrams for each of the chosen effects, compile a list of components for each of the subsystems, test the components to make sure that they're within the specified tolerances and are functioning the way they should be. This is going to be important from some of the ICs that I bought because they're going to be eBay specials. Create and test subsystem circuits. I'm going to make some circuit modifications to the diagrams that I'll be showing here in a moment. In the upcoming reports, I'll be going over the revisions I make, report my findings, and keep a record of each of the tests. Start designing pad stacks, footprints, and circuit diagrams for the system. Start designing the board layout for the PCB. Solder the components into the board once the PCB prototype's finished. Test the board prototype and make sure if there's any revisions that need to be needed, I can make them in time. Prepare the housing for the pedal. I'm going to enlist the help of a 4-year-old to help me with the graphics, which I'm pretty excited about. Assemble the pedal prototype, test the prototype, and then conduct my final presentation. The system and subsystems. I broke down the system into 7 subsystems. These systems are the power circuit, audio circuit, the fuzz effect, the chorus, the phaser and vibrato effect, the delay and reverb effect, and the housing. Breaking the systems down into manageable portions will make the process of writing the documentation a little bit more organized, and it'll help manage the workload. The power circuit. The way that I'll be providing power to this is by using a 9-volt power supply from the existing pedal power supplies. So the input on this is going to be a standard 2.1 millimeter barrel jack connector. The power will be controlled by an on and off switch, and the power for each of the effects will be wired in parallel. So everything will be powered constantly. I may need to work out a power solution if uh, one of the effects loops is pulling more power than expected. The audio input output circuit. The way these switches work are pretty interesting. If the switches are in the open position, they'll basically act as a bypass for the audio input signal, so they'll just go through. And if the switch is closed, the signal will run through the effects loop and make its way to the next switch. The green being shown is for the closed switch path, and the blue being shown is for the open path. The fuzz effect. The circuit is fairly simple, and it does not use any ICs in it. The fuzz became pretty popular after Jimi Hendrix used it with the wah-wah that gave him his iconic sound. Fuzz effects utilize at least two transistors to create a noisy, fuzzy sound as the input signal is pushed through the circuit. The more transistors it has in the circuit, the fuzzier the signal becomes. And here's a better look at the diagram. I think I'm going to take out the external control for the volume since it's kind of redundant and it can cause the audio signal to become really harsh. And I'm not trying to get an overdrive. I'll replace it with an internal trim pot and find a happy medium for the signal while still giving you the option to adjust it if you want to do that in the future. The coarse effect. The coarse effect will take the original signal and mirror it at a slight delay at an octave that's higher or lower. This gives the sound an effect of two guitars playing at the same time, like a chorus. The main source of this effect comes from the Panasonic MN 3007 BBD, or Bucket Brigade device. The Bucket Brigade device functions as it sounds, kind of like a group of people passing buckets to each other. A BBD uses a line of capacitors that pass the analog signal to the next after every clock cycle. Right here is a diagram, and the ICs that are currently being used are going to be the 4458 dual op amp, the MN 3007, a CD4047BE, and a LM558. Phaser and vibrato effect. These are really fun effects to mess with. The modulation effects, like phasers and vibratos, can totally change the sound that a guitar puts out to the point you can't even tell that it's a guitar that's making that sound. Phasers, tremolos, and vibratos work by changing the angle, frequency, or shape of the wave. A phaser effect moves the phase angle of the signal ahead 30 to 90 degrees. A vibrato effect modifies the signal frequency so that it sounds like it's wobbly or vibrating. I'm going to put a two-position toggle switch that allows you to switch between the two effects. And here's a diagram of that. The ICs that I'm using are 3 of the LM13700s and 2 of the TL072s. The delay and reverb effect. This effect uses 3 BBDs. If the timing or the clock cycle is set to be short, the sound will result in an echoing effect. If the timing or clock cycle is set to be long, the sound will have a long reverberating effect. Most reverbs and delays that are made today use digital logic, and the PT2399 is the alternative for most BBDs nowadays, and it really makes for a more simplified circuit if you go in and look at them. And here are the ICs that'll be used. It'll be a TL072, an NE571, a BL3102, and a BL3208. The housing. The housing that I decided on is the aluminum 8-inch by 5-inch by 2-inch switch enclosure from Kata Electronics. I've messed with these before on other projects. They're easy to cut and drill, they're robust and durable, and compact. If you look in the picture, Tata made a mistake on the order and they sent me the 6-inch by 5-inch by 2-inch instead of the 8 by 5 by 2. But once I get the correct enclosure, this is going to be the design layout that I'm going to go with. The components and budget. The budget constraint for this project is 200 bucks. My expected total cost for this prototype was going to be, I think it was $60 to $120. Virtually all the parts that I bought were found on Tata. I couldn't buy some of the capacitors or resistors individually, so I had to buy them by tens. So the actual amount ended up being $69.70, and the package I got was pretty heavy. It had about 512 components in it altogether. I had to order some of the special analog chips from eBay. The total eBay cost is $28.46, and I'll have plenty of extras. So here are some of the costs of the components, and it shows you what I'm going to be using for each of the circuits or each of the subsystems. This one's for the power circuit. This is the audio circuit. This is the fuzz effect. The chorus. So the fuzz effect, the total cost of it's $3.36. The total cost of the chorus effect would be $5.49. The phaser and vibrato, the total cost for that was $17.56. And the delay and reverb was $14.21. And the housing is a $10 enclosure. And here we have the total components that I'm going to be using are all the components from each of the subsystems. It came out to 268. And the total cost for it, if I was producing these just at cost, it would be $67.99. The actual cost that I paid for was $98.16. And luckily, I will have plenty of components to use if I kind of mess anything up. Obstacles. The main obstacle that I'm going to be facing right now is just going to be getting the integrated chips. Due to world events, obtaining some of the chips I need will prove difficult. The chips that I had to order from eBay are two of the Belling BL3208s, two of the Belling BL3102s, one of the NE571s, and one Panasonic MN3007. And by ordering some of these chips from eBay, I run the risk of getting counterfeit chips or chips that aren't what they stated to be. Here's my timeline. Current and upcoming tasks. I'm currently on track for weeks 5 and 6, but as I mentioned before, I can only test 2 of my circuits due to the supply issues. I'm set to receive my required ICs by May 2nd. To make up for this, I started working on the circuit diagram for my board prototype already. Okay, conclusions and updates. Conclusions, I still feel pretty comfortable with continuing the tasks I stated in my initial proposal, but I just need to be wary of the ICs that I'll be receiving in the next 2 weeks. The ICs are going to be what makes or breaks my initial plans for this analog system, and I probably should have taken into account the global chip shortage to begin with. Some updates. Shipping was faster than expected from Tata. I received my order for virtually all the components. As I mentioned, I received the wrong size housing, so I reordered a new one. 2 of the eBay chips have arrived already, and I'm going to start testing them here in a couple of days to see if they work as intended. And thanks, everyone. I'm excited to show everyone what I have for next time. Hopefully those ICs will be in, and I can show you off some of the cool effects. Thanks for sticking with me through this, and have a great night.